Greetings, this is the presentation for the design and implementation of the automatic defogger control systems. This job was done by Kevin Adames and William Noguera. The main objectives of this project was to remove the condensation from a windshield using this system. It was done by monitoring the temperature and humidity of inside and outside the vehicle. It was set to be made in less than 5 minutes. We wanted to design and implement a ventilation system to provide dry air to the windshield and remove that condensation as quickly as possible. It was said that we wanted to use this system with the same power of the battery of the car, so we used a car lighter to supply the power. For the decision making of the project, we made a decision matrix taking into consideration 4 different scenarios. There was one that could implement a system for controlling the 3 buttons that come with the air conditioning system in the vehicles. This one was not selected. Was modifying the full chamber was another scenario. It was very expensive and we don't have the mechanical experience, so we made a combination of scenario 3 and 4. It was implementing a system with air compressor and air tanks and simulate this system in a typical cabin using a fish tank as our artificial cabin and controlling the conditions inside the cabin for the testing and implementation. Well, new aspects of the project comparing to the initially set up idea. We have a new pneumatic system combined with fans, a new control system combining these 2 fan and air storage system, and also we simulated the system in a fish tank for the representation of the interior of the car cabin. Here is presented the list of components, the most relevant ones. We use as a main microprocessor the Arduino Nano. We have the sensor for temperature, humidity, and pressure. We have the solenoid valve, air filter, and air storage tank for the pneumatic system, and also circuits. We have MOSFET terminal blocks and the voltage regulator setup.
The system runs on 12 volts and 10 amperes. It can be seen that each component was going to work correctly when the system was turned on. Then, due to the 12 volts and 10 amperes current, we verified which wire we needed to use and perform an analysis. And we observed the cables use resistance effectively and temperature increase, and there is no concern that the system suffered from the temperature increase. Here is the analysis that we make. We can see that the power supply 12 volts, 10 amperes. It have a total of 120 watts, and the AWG of the cable was 18, and the ampacity it was 16 amperes, so it can resist it.
For some of the system specification, here we have the connection between the valve switch, the compressor, and the 2 blowers that we implemented. We're using terminal blocks and MOSFET to switch on and off every component. Here is presented the voltage regulator configuration for having a regulated 5 volts in the output, and we have the connection in pins between sensors and Arduino. Here we have the full electrical diagram. Here we have the 3D model of the PCB done in ECDA program, and we have a photo of the final work done on a PCB board.
This schematic is a mix of a PNID with pneumatic symbols because it's for better understanding. And here we can see the compressor, the 2 air tanks, the sensor, the filter, and the solenoid valve. We can see that the pressure sensor is connected to Arduino Nano and the electric solenoid valve too. There is supposed to be the switch, but to see it better we put it that way.
Here is the linear relationship between the pressure that we measure with the sensor and the analog value that the pressure sends us to the Arduino. Here's the formula that we use to calculate at what temperature we will find the dew point, and here's the serial monitor monitoring this temperature, internal and external of the vehicle. For testing and validation purposes, we have the setup for the fish tank simulating the interior of the car cabin. We close it out to create the condensations and perfect conditions.
Here is the after and before.
Here's a short video of the system working after the dew point and the condensation is made. We made the ideal conditions for this to happen and see the work of the system and remove that condensation.
The testing and validation full video. We connected to the car. Then we turn on the compressor. The compressor we turn on it then for a second because the pressure is zero. And we put out 45. Now we make a pause because we need to do the dew point condition. We can see that the dew point condition are perfect, so we turn on the system. And here we start to turn on the compressor. The fans start to start beginning to take out the dew point condition. This part is what we see on the slide before. We do it again.
Well, conclusion for this project is that regarding the averages, it can be concluded that each of them has been met. This project is excellent for educational purposes. It will be a great opportunity. This system can be modified in the future for a better space, regarding the air tanks and and where to be located inside the vehicle, and it could be a very good opportunity for patent and implementation in future vehicles.